All right, I think the stream is up. Hello, everyone. Happy Tuesday. Be doing the kind of usual office hours today. People join and ask questions. We'll have to cover the questions. If no one is kind of asking anything or has any particular questions, then I think we'll just kind of cover a little bit on conditionals, kind of some of the main takeaways, and then I might go over um, just some like programming activities that are related to the homework and lab, so that you can use those potentially if you get stuck. I won't be like doing the lab or homework for this week, but showing you kind of like, oh, using a for loop in conjunction with like an if else statement. So, kind of showing you the application of what we learned last week with loops and then kind of applying the content from this week in the if else statements within that, which is also kind of the main topic of the following week's module. And it goes into some like algorithms a little bit. So for this week's kind of lab and homework, while we do combine loops and these conditionals, it's not in a too kind of like complex or heavy way. So I just typed because I'm trying to be better about kind of giving like timestamps for those of you who watch the video after the fact. So yeah, until someone asks a question, I'll just kind of go over some like key aspects of conditionals and some of the main kind of takeaways. I know it's still early in the week, and so people may have not looked at this. It is only 6 pages, but hopefully you at least know of like if and else. But if you're tuning in and you haven't looked, no worries. Um, but I would say, so if you did look at the lab, it's just, I think, what, 3 functions? Let's see, or four. Yeah. Okay, so it's 4 functions. And there's no kind of written part. Like I know last week with their first question was kind of all about lists and getting you to, it was still writing code, right? But it was more of kind of this written thing because I really wanted you to understand this aspect of lists. So I was tempted to do that this week for conditionals, but then I thought kind of OLI really broke it down enough and gave all these examples right here in particular. So I think page 26, the second page of this module, is pretty key at kind of getting the kind of core aspects of conditionals, right? And I think the first one is the use of and or right here. So we know bools are, true or false, and you have to capitalize it, right? Which is something that always gets me. But the kind of use of and or in these, so, right? So if we say, 5 greater than 10, that's not true. But 10 greater than 10, still not true. 10 greater than or equal to 10, true, right? So it's kind of applying these operators to it, which is mostly for kind of like numeric things, or you can also do strings, like test equals testing. That's nope. But then that's true, right? So I would say, equal to or not equal to are kind of the biggest ones you'll use, but definitely can make use of the other four right here for more kind of numerical inputs. And I'm pretty sure for maybe both the homework and the lab that a kind of string comparison in this way will be beneficial, or at least one way you could solve kind of one of the problems. So like also if I did like, so that's true because, right, the string rock is not equal to the string paper, for instance. Um, so yeah, kind of having a grasp on this, how you might apply these relational operators and get true or false, which kind of builds into this next part with the and or. And again, if it's an if statement right here, it's going to, whoop, uh, yeah, and so if I had like an else there, right, it wouldn't hit because the true part, this is true, right? The if gets evaluated to true, so then it executes if body, and if it's not the case, then it hit the else. But kind of programming like that in the idle window is a little annoying, so I'll open up another file here. I already have an office hours file, just in case we need it. All right, and we have a question. I wanted to follow up on someone's Piazza question asking why, when s is less than or equal to num and num equals 17, why the response is still printing 20. I think that has something to do with how the while is evaluated and the order of printing while evaluation. Can you explain further? Yeah, let me pull up that. Trying to I don't know if I have a student view and I don't want to just show the teacher view for Piazza. Um, so I did respond to that if you saw, but I'll walk through it too because I know textual responses can sometimes be not ideal. Hold on, I'm taking a screenshot of it. This is maybe the best way. Okay. Right, so it's this question, I believe. Um, and let me look at how that's displaying on the stream. Give it a second to update. I just took a screenshot and put it into Paint, but I think it works. So as you can see on this browser question, there's a while loop. This is for part 3 for the second homework, right? And so it's supposed to print, that was the input number if it's divisible by 5 or not. So if you input 17, then you need to print everything up to there that's divisible by 5. So that would be, the values of 5, 10, and 15, right? Um, and it kept going kind of one further and printing 20 for this person, right? Even though they had this condition up here, um, right there, the while s is less than or equal to num, uh, right? So as being less than 17 because num was the input number. So they had s, which is the value that's being printed, less than or equal to the input, which in this case was 17. Right, so that's kind of what that was there. And yeah, and so then they were kind of executing this code, and they were getting it was printing, 5, 10, 15, and 20, kind of actually just like here. So when I called this function, I basically put their code into my Python idle and ran it, and I added an extra print statement. And so this was exactly what the function was calling. And so for s, I just added this little bit right here that shows you it's printing s. And then I added one right before it that was printing the value of x. So when it's first called, this while loop, right? So x equals 0, s is 0, and then we have this num and input, which was equal to 17 based on the call. Right here you can see. Kind of wish this had a better highlighter. But so those are kind of the 3 values we're working with right now, right? X, s, and num, so 0, 0, and 17. And so then it hits this while loop, and it's okay, while s, which is 0, is less than or equal to 17, execute this, and it's okay, well, that is true. 0 is less than or equal to 17. So then we'll run by this. And we have x equals x plus 1. So then this is, 0 equals, or x is variable. So then we have x equals, and at the time, the value was 0. So this is just saying, sorry, I'll actually keep all of our values in real time right here. So now this is saying x equals x plus 1, which is the equivalent of doing x equals 0 plus 1, right? Because our value of x is 0 right here. And you can also verify that there. So then at this line, we have x equals 1 now. And then it does s equals x times 5, and we know x is now 1. So then we expect s to be 5, which it is. Call s until it's false, but we'll still print the value when it's false. Right, right. So this will just keep, so the idea with a while loop is that it keeps executing until the kind of condition is false. So if you do something like while true, See, I told you I always do the lowercase. It'll literally just keep going forever because there's nothing to make that value false. Um, Also, if you do Control plus C on Windows, at least I think Command C will do it. It'll stop something from getting stuck like that. So that's the idea with while. So then it'll stop executing the body of code, which in this case are these 3 lines right here. Once this gets evaluated a false. And so, it was doing that. So then we had x equals 1 for the first iteration, and then s became 5, which I think I already set, right? And so then it prints for the first time, and it prints 5, which is true. And then it loops back again. So it goes back to the while loop and it says, hey, what's the value of s? And it's like, okay, well, s is 5 now. Is s less than or equal to num, which is 17? It is. So then it does the whole thing again, where x then becomes 2, and s becomes 2 times 5, which equals 10. And then it prints 10, which is correct. Does it again, and says, okay, well, 10 is less than 17, right, because it's still evaluating to true. So then x becomes 3, s becomes 15, prints it. And so technically it should stop there, right? Because all we expect is it to print 5, 10, and 15. But then, right, so it just prints 15. But so now our value of s is 15. So, we're done executing this print statement. It goes back to the top and checks the condition for the while. And so it says, hey, is s less than or equal to num? And so our value currently is 15, less than or equal to num, which is 17, which evaluates to true. So then, x becomes 4, sn becomes 20, it prints s, which is 20, and then it goes back up to the while loop, and that's when it fails the while loop, right? It becomes false because then s is 20. So it says, hey, is 20 less than or equal to 17? No. And so then it stops executing the while loop. And I think, well, I don't know if it was public. There's another question kind of that ran into that too. It's like, oh, it's like printing one too many, or it's not printing enough. And I would definitely encourage print statements throughout. Because like initially, I mean, it's like once you know it, it's like, oh, that's kind of like a thing to catch. Um, but when I first glanced at it, I didn't like readily know. I was like, oh, why is it getting 20? I mean, I'm looking at this. I guess I don't technically know off the top. And so I went and I was like, all right, we're printing s. I know num never changes, so what's the other variable that changes? And it was x. So then I was like, okay, well, I'm going to add a print statement for x as well, just so I know, right? So I can keep track of these changing variables. And by doing that, it became apparent like, oh, okay, well, it's failing the while to appear because it's 15, then it gets printed and all. So then I think I just suggested, yeah, moving it, right? Yeah, arranging the code so it increments after printing should prevent that. But then you'd have to change s, right? Because then s would print 0. But so it might still print that false value. What's the false value in this case? When it says use, it still might print that false value, like the 20 in this case, or I think that kind of, I guess I wouldn't, yeah, I don't know if I'd say risk, but yeah, it's just something you can get in trouble with all kind of loops actually. It's just like, especially with while loops, right? Because I think especially when you're kind of doing range or setting like a hard limit, like for x in range 10, then you're not really modifying that range 10, right? Like that. Um, that's set, but when you have a while that you're checking and you're kind of modifying the variables in the loop, so in this case, right, s we were constantly modifying after each iteration, that can definitely cause some confusion and cause the while to do another pass when you think it won't, or to fail when you think it will continue, right? And so another case that you can definitely run into is, so let's say I have a list of even numbers. Well, actually, let's put like a 5 right here. Oh, before I go down my little list rabbit hole, incrementing after printing. So it's just kind of like, I don't know, like code, not code preference per se, but like in this exact code block, if you printed before you incremented, right, then s would be 0. So if you put this print line before the x, then the very first time you run it, you're gonna get s equals 0 with the way it stands now. So then you would need to like, start your s at 5, for instance, or something. So it just kind of like changes how you're gonna have to write the code, but it's not, I wouldn't say that's like a big change, right? If you just move the print up above the x, start your s at like 5, and then maybe you have to change your x to 1 or whatever. But I think it's just kind of like code structure. But another area this can get into trouble with is, so if you have a list like here, like with my list, and you're doing like a while or a for, like for x in my list for x, right? And then maybe in this for, you have like, oh, copying's always terrible in this. Print my x, and then maybe if you like remove it, then you can, well, I guess it's not so much the case here. But if you're like going off the length of a list, right? And range length of my list, and then you're making modifications to that list, then the length of the list becomes different, right? So then we have, this is really tiny because I just popped a bunch of stuff. But I think this comes into play for both the lab and the homework for this week, is you may be iterating over a list and you may need to do something. Like remove, like if I wanted to remove the 5 from my list up here, right? And then if I'm going off of the length of my list, which is 5, and then if I'm looping through the code, 0, 1, 2, sorry, that's the second index. And if I remove that, then my list becomes, just 2, 4, 6, and 8. But my list, what is it? 5, right? Right, so there's my new list because I removed 5. But now if I go into that same index where my list of 2 was 5, if I do it now it's 6, right? Because we removed the 5, so now it's 0, 1, 2. And so that can definitely get you into trouble, is when you're like kind of looping through a list and you're going off the length of the list for something like in your for or your while, if you're counting on the length of a list, but then you're making modifications to it, like removing or adding, then the length of the list gets changed, and so it can affect your loop. So definitely I would say anytime you're doing a loop, especially if it's a list and you're going off the length, to like always have something that's like, you know, there's plenty of ways you can do it, but that's just kind of how I like to have. Um, and I feel like I think I still do that today for like any kind of list, just because when you're adding and removing stuff and doing all these changes to lists, but you're using them in your loop because you need to, right? Because you want to go through every element. Um, it can definitely cause you some trouble. So, especially early on, I would say almost like every variable that you modify in a loop. So, for instance, here, x and s were being modified, and then we just have a print statement. I would say it's, if even if you're not having trouble, still it can't hurt to just kind of throw a print statement in so you can kind of trace the values of the x and the s, right? So then in the case for, yeah, this, if I, was modifying more variables here, I might want to print the length of my list and then any other kind of things I'm tweaking here, just so in my head I can be able to, maybe debug it a little quicker. Or if I get an extra value I'm not expecting, I can say, oh, it's because, I noticed the length of my list did get modified on the third iteration of this loop. Well, what am I doing here? And so those print statements can kind of save you on that. So yeah, we kind of talked about relational operators. I think that, so kind of getting back to on lab, why I didn't really have like a written kind of question to begin it with, is because I really like kind of the breakdown on this page 26 of the OLI module and all these practice opportunities. So just in case you're not familiar, these little dots mean it's kind of like paged, right? And I think this is really good practice. So I didn't include any kind of questions like this on the lab because I would expect you to kind of either do these or already have mastery of it. Um, but I think these are like super helpful, right? And if you are ever confused on any of them, you can readily just kind of type them into your shell and get the answer if the feedback doesn't help you with the hint. But I think a big part of conditionals is knowing that you can kind of use these operators on it, and in particular for kind of like strings, right? Remember, like rock equals rock or whatever. And then obviously doing like number comparisons. And then you can, with and or, it can start to get a little tricky too, but this table is super helpful. Um, and I remember when I was first learning the program, I had this table, not no lie, but like a different one pulled up, bookmarked, and I think I referred to it for maybe like the first like 5 years of my programming life, um, just to kind of be sure because right, you might have some function that's like if you know like x and y are greater than z is one case, but also, well, maybe if z is going to be like less than x times y, or so right, it can like, especially when you're having variables, and you can be like, okay, what? So you have all these and ors and all these different kind of evaluations of true and false. So then you're gonna want to like break it down into being like, what option do you be like z, right? I'm like, okay, that's gonna evaluate to true, and then I'll know, my value of z. Okay, let's say like z is 10, and I know x is like 5, and y is 1. So then I'll know, okay, well, it's going to be 10 is less than 5. That's going to be false. So then I'll say, okay, this will be false. And kind of like write that in my code and comments. And then you can kind of replace it with like, okay, so this is going to be if true and false or true. And then you got to think how it's going to be like kind of executed here, right? So it's like, okay, well, true and false, what is that? So you can go to the table. Is it true and false is false? Then you might want to go and replace it and say, okay, well, now we have false or true. So we go false or true, true. Okay, so that's going to evaluate to true. So then you basically know, okay, this if statement's like, going to get hit. I don't think we have any in the homework or lab particularly that are kind of that complex. Um, that, I mean, you could, I guess, maybe potentially make one that complex, right? Because some of them are a little open. But yeah, I don't think it really comes to that. But that's just still something good to know in the homework or for the future of the course and all. And same with not, right? So like not true is false, right? Because not, you can basically think the operator or the opposite rather. So, and I didn't put any like, I know that's unfortunately common for a lot of intro programming courses to try to do like brain teaser ones where you have like a huge if else statement and you start throwing around a bunch of nots, ors, and ands, and it gets a little annoying. Um, but yeah, I think those are pretty uncommon in like a realistic setting. Like, I don't think you would personally make a big if else statement that has four conditions and a bunch of nots and ors and ands in there. So I didn't think it was too needed. But yeah, I'd say, especially too for the lab and homework, if you are definitely throw a bunch of print statements. Again, I cannot emphasize enough, like kind of like adding print statements within the body of your loops, so you're able to kind of trace these variables, especially anything you're incrementing, especially with lists. That'll help you a lot. I might even type that out right now. So yeah, that's definitely one thing that might help with the homework. Again, I don't think any of them get too complicated with it. Um, so if you do find yourself kind of going down like a rabbit hole, maybe ask for help on Piazza, right? Because it's not the intention that you'll have these like hugely complicated if else statements. Just kind of getting used to using them. There is like a rock paper scissors question for the homework, and I think that might be a potential like longest if statement that you might have for the homework. But let's see what else. Right. Oh, kind of another good thing too for print statements, kind of relating back to this, is to like, so if I do have this large if statement that, kind of has all these, like printing out the value of this is like totally useful. So let's say those actually had values. Um, then useful would be equal to like the true or false here, and then so you could print that out. So then I might have like a print statement that's like that to let me know what it's evaluating to. Because sometimes you can think, especially when you're modifying these again, I don't think I can emphasize this enough. Like if your x is 5 and maybe you're expecting it to be 4, and you're like, well, 4 plus 1 is greater than 3, but really it's like, oh, x is technically 2 at this point, but I was kind of getting mistaken. So print statements are huge in that regard. Yeah, I know like this goes into the whole grader thing, which is kind of a common first example. We definitely won't have anything like that. Um, but also, yeah, this is kind of more reflective. Oh yeah, there's kind of a value. And I think I will probably pull up the lab and homework now and then maybe like briefly kind of talk on some topics that the questions are targeting and potentially give any hints for those. Just give me 1 second. Someone's at my door. All right, I'm back. Sorry about that. Let me pull up the lab first. All right. Yeah, so kind of same topic, not topic, but concept with the lab and homework of really trying to emphasize the kind of core concepts for the week, which in this case were the use of conditionals with if, else, and elif statements. In addition to kind of applying them with loops, which we tackled last week. So nothing as complex as what we might get into the following week, which is kind of focused on combining them. But a lot of these lab and homework problems might require you to like write a for loop and then within that for loop do an if else statement. So not like some huge branching computation where you'll need like a for within a for within an if else, and then that might trigger a for, nothing like that, um, which we can kind of see here. So I'll just kind of lightly, I guess, touch on all of these. And again, if you have a question on anything, even if it's something from like last week or the previous week, feel free to just ask it. All right, so I'll just go in. So this says complete. Oh, let me the lab for this week. So complete the function vowel counter that takes in a single string and returns the number of vowels present in the input string word. The input word might have varying cases, such as apple and apple, both of which would have A and E, because those are the vowels, right? Make your code a bit cleaner if you use a particular string method. Introduce how many checks you need to do. And the vowels check for are A, E, I, O, and U. So we left off the whole sum times Y thing. And so if we called vowel counter testing, right, we would return the value of 2 because there's a single E and a single I. Right, so on this one, let me download the Python file. Whoop. Right, so breaking down the kind of thing, which I really like to do. So, right, we need this function vowel counter takes in a single string. So we already have this. We do know we return a value. And it might have varying cases, such as apple and apple. So, I might say, okay, word has apple, apple. So like altering cases. And it's okay, a bit cleaner if you use a particular string method. No. So instead, is that total number of vowels or x divided by 5 for vowel type? Total number of vowels. I'm not sure what the second part's getting at. I'm not sure what x divided by 5 for vowel type is. But for in this case, right, we input the word testing, and so then there's an E, which is a vowel, and then I and a vowel, so then we return 2. And in the case of apple, both would return 2 because even though this A is capital or whatever, right, it's still a vowel, so A and E, so this would return 2. And then in our function, if we input a lowercase apple, then we'd still return 2. And then these are the vowels to check for. Switch from cases. As a max count would be 5 for the latter. Oh, like if a word had like 2 E's in it, there's a yeah, there's a delay on the stream. I wonder if I can make there no delay. But right, so if you're like what's a word that has 2 vowels in it? That's the same. Right, so swimming, for instance, would be 2. And I'm gonna type that here. So if anyone comes retroactively. That's a good question. Try to make it say eyes and it says is. Oh well, I think they get the point. Um, but yeah, that's a good point. I should have probably used a better example than testing. I might update that actually. But so we do need to account, right, for these upper and lowercase instances. And so I was like, oh, maybe a method would help. So this is one way you can do it, right? You don't have to use a kind of string method in here. But maybe I'm in here and I'm like, okay, well, what can I do? Strings is arrays, strip, no, substring, length, love length. Then it's like, oh, what? This method returns a string to lowercase. Maybe I want that then. Click that. Oh, like the input, even if it has a capital letter begins with, or anywhere for that matter, it becomes lowercase. Huh, could be useful. So maybe I want to use that. And see, that's a fun function. And then I know I'll need to check for these different vowels. So then maybe I'll want to just make it like a list of them for now. Right? A, E, I, O, and U. This is one way you could do it. right? And now that we know we have that kind of nice method we can use, we do not have to have like capital versions of them, right? Because we can just do something to the input. So then maybe I'll, like check for the presence of any like vowels elements in the input word, and then keep a counter of them somehow, right? So then it's like count equals 0, and then, you know, if there is a vowel, I would want to like increment count. So I don't want to like get too into solving this, right? Because we'll be doing that Thursday. So that's kind of one approach you could take to it, right? You'll kind of know, you'll need to return a number based on how many vowels, so you'll need like kind of a counter variable. Um, it's maybe nice to just have all the vowels stored in like a single thing you can check against. So, and we did just learn about lists, so I might throw those in a list and then, look for a way that I can check if any of these elements in the list are contained in this word that's input. And then, maybe applying something to it so I don't have to check for like capital vowels versus lowercase. So yeah, I'll just kind of leave it at that. So now the next one, let's write a function completely odd that takes an integer number. This function should return true if all digits are odd and false if otherwise. So completely odd with this because 9, 3, 7, 5, and 1 are all odd. So it does return true. But 9, 3, 2, 9 returns false because, 2 is an even number. Yeah, which says right there. And we count 0 as an even number, which is actually something I had to look up. But then I think it gets all into like if anything modulo 2 becomes a, just close out of this, modulo 2 becomes like an even number, right? So, 0 modulo anything is like 0. So then I think maybe that's why it gets counted in. I don't know. There's a whole number theory thing in there that's beyond me. But okay, so I guess I'll want to check then. Well, I guess, so if I know if it's modulo 2 equals 0, that's one way to check if it's even, right? Because, all the odd number, all the even numbers will be like divisible by 2. So, that's maybe something I want to do. Modulo 2, right? But I want to do that on like a per digit basis. How do I get a digit? So I'll kind of want to think back to how to get a digit for like an input int, which we did talk about kind of at one point. Or so we talked about how to like remove a digit from the last lab, I think it was, right? Where we did. So let's say we have 978. Do that. It gets like rid of that digit, right? It gets rid of 8. Um, so don't forget that. So then, we can do 97, modulo 10 again, we can get a 9. So I know how to remove a digit from the number, but now I'm like, okay, maybe I'll mark that down. So, the ones digit, the rightmost digit, whatever you want to call it. But I'm like, how do I get that? So I was just doing like, modulo to get values. And I know if I like do floor division on 10, I can drop the last digit. So what would happen if I do, okay, so I do modulo 10 on it and I do get the last little ones digit there. Maybe I want to try it again for all these values. And it's like, okay, well, maybe I am getting, the digit value I need by doing modulo 10. Okay, so if I know how to get that digit and then I know how to remove it, maybe I can kind of do this in a cycle till I'm at a digit. And then when I get the digit, maybe I'm able to check if it's even. And then, if I ever, or yeah, so then check if it's even or check if it's odd might be better. So, if it's like whatever digit want to, it's like not 0, right? And so then maybe if I ever fail to check, meaning the digit's even, then I could just go ahead and return false. So, don't want to dive into that too much, but, just kind of wanted to play off this one a little bit again as one way to solve it and getting used to the kind of modulo. The movie ticket is probably one I won't even really walk through right now or touch on, just kind of like using conditionals to, have this kind of structure for buying a movie ticket based on an input age, right? And originally when I was writing this, I thought about using like more like poorer wording for this, right? Like all of these are kind of like cookie cutter the same, but I almost was tempted to make it like more worded poorly, because that's sometimes what you will encounter, right? When you're trying to get kind of like specs from a customer, or if like you're working with a teammate, they're like, hey, I need you to implement this, or if someone you're working with on a project is like, yeah, well, you're gonna need this kind of thing to do these 4 cases, and they might just tell you quickly, um, and so you'll kind of have to try to like interpret exactly what they need the cases to be. But I wanted to make it a little more straightforward than that. But that is something, especially you could get something that you'll be working on in PUI or for like your capstone project or whatever. And then the client's like, yeah, well, if the user says they're under 18, just kick them out of the system, right? And so then you'll implement that, maybe using an if else. But then they'll come back and say, actually, no, if they're under 18, take them here and let's find out if they're between like 13 and 17. And so you'll have to kind of keep tweaking it as these kind of specs and requirements change. Um, yeah, so that's almost what I was tempted to get at, but yeah, didn't end up doing that. So I don't want to touch on this really, because I think I might just give away the answers, because kind of just transcribe that to code is basically what it is. And then for this last one, completing an average grade, which is kind of done a little bit in OLI for this grade thing. But on this, you get a list. You can always assume that the first one's a name, right? And you can always assume it'll at least be 2. Actually, I'll read through it again and break it down like I would normally. So it takes in a single list corresponding to a student's name in the first index. Okay, so then right when I read that, I'll know, boom, the name, the first index, I can get the name. And their grades in the following indices. So then grades equals everything else, 1 to like end of list. Right. So list can look something like this. Note there can be a varying amount of grades in the list, so it can be up to any size, right? So in this example, there's 4 grades. Maybe there's going to be 10 for the next one we try it with, or 20 for the next. So it's like, okay, well, end of a list. I know this gives me some useful information, right? So I can know which kind of indices to go into, regardless of the size they input, because we can get the length of the input list. Yeah, and so we'll need a name and a grade. So that's like all grades. And then what are we trying to do? Function should calculate the average. So then I know I'll need average, which is 0, of all the grades present in the list. So then when I read like all the grades present in the list, that makes me think I'll need to iterate over this list, right? So I'll need to add this value to this value to this value. So I'll need to loop through the list, and I can ignore this first index, and I'll just need to add all these values up. And then to get the average, remember, if we add it by 4, or add these 4 elements, we would just divide by that many elements. So again, you could use the length of the list for that. But basically, if you read something like that, that's like calculate all of the blank present in the list, you should kind of know, hey, maybe I need to like iterate over this list and try to get every element. So, then I might have this like running average that I do add each of these values to as I go through the list, and then eventually kind of maybe divide it by 4, or it could be 5 or 6, however many it is. But thankfully, length of the list tells us that. But we do need to omit the kind of first one, right? The name. I don't want to get in trouble with that. So then maybe something you could do is pop, right? So if you look at the list documentation, you'll know pop will remove an item, and I believe it's at the specified index. So if we know the first element, which is 0 index because it's a list, is always the name, then doing pop at this index will return the name for me and also remove it from the list. So then actually, I will walk this through in case it's confusing. Let's see if it copies and pastes well. No. Yeah, I want to also test this because I don't want to misspeak about pop. Oh, whoop. Got the extra. There we go. Okay. So, now if I have name, pop. So it did remove that first element, which is good. And thankfully with pop, it also assigns name. So now if I do the length of my list, 4 is correct, right? So then if I, loop through the list and I'm adding up all these different values, 229, and I'm dividing it by the length of my list, 82.25, which is correct. So, you can do something like that. There's a ton of different ways to kind of solve this. But, that's potentially one way that could help you out on it. And let me type in here. Do these even have timestamps actually? Now that I'm looking at my interface, I don't see timestamps, but I think if you progress along, after the vid's uploaded, chat appears where it would in the video. So 10 minutes in, you wouldn't see this message. But if you jump to 47, you would. Hope that's the case. Yeah, so that's kind of the lab. And let's check out the homework. Oh yeah, let me get that Python file. Right, so the very first one we have is this pizza order function, which does come with a list of toppings, which is a do not modify, please. So yeah, also same idea on the homework for this. Maybe a little more heavy on the loops than previous ones. I think half of these will require a loop, but the other two maybe won't, depending on how you solve it, right? But for this one, I would say word match is the difficult one, which I didn't put last. I know last time dice game was the quote unquote harder one, a little more lengthier for sure, and that was at the end. In this case, word match is our difficult one, I would say. Building off kind of what we did on the lab too, I tried to tie the lab maybe a little closer to this problem. So hopefully you can use some of the stuff from the lab, at least concept-wise on here, and then maybe apply one more thing that we learned this week to get at word match. And with kind of unlike the last lab and homeworks, I think there's no kind of outside documentation you might need. So for the first homework, right, I gave some documentation and hinted that you might need the random module, but that's not really the case for any of these. You can solve these for sure without using any kind of extra functions or libraries that we did not cover. But again, if you do kind of go searching or you already know of other function libraries that you want to use, you are more than welcome to, which is kind of always the case for the course. There's no one right way to solve it, right? And I don't think probably for the rest of the course there will be any more kind of forcing of use a for loop to solve this or use a while. Particularly not for this homework too. You can use a while, you can use a for, you could not use any. Just however you see fit to solve it. All right. And also, yeah, as the comment kind of says, don't modify that list of toppings. But let's read what this actually does. Takes in a varying size list of strings, order, corresponding to different toppings on a pizza. Okay. So, maybe I'll do Order is a list of strings, and they said it's toppings of a pizza. Okay, well, I have toppings up here. So, maybe I'll be like pepperoni and cheese. Okay, let's keep going and see what it is. You should compare the items in this list, okay, to the list of toppings present in the function body called toppings. Okay, compare order items to the toppings items. Okay, so I'll be doing some kind of like comparison. Um, Note that all these toppings are pluralized, ending in an S. Do not modify this list. So I'll look back up. Pepperonis, onions, cheeses, peppers, pineapple. Okay, yeah, they all end in S. Great, great, great. And I think too, also, I was like, if I'm ordering a pizza, I'm probably not gonna say like, hey, let me get a pizza with pepperoni and onions. Or I probably will say it like that, right? I'm probably not gonna say, let me get a pizza with pepperonis and onions and cheeses, but maybe I am. Um, but either way, so I feel like if you were gonna order a pepperoni pizza, you're either gonna say pepperonis or pepperoni. And so part of this not modification thing is like, I don't want there to just be a little kind of redundancy in it. I wanted you to try something else to check for the case, which we'll dive into. Right. Plenty S, yeah. So if one of the input items is not present, it should print that the item is being added to the order. All right, so what's another pizza topping not on here that I could add? I don't know, ham. All right, so because I do want to have a kind of a case that meets this, right? So I copied these two kind of from up above. I purposely didn't pluralize cheese though. And I want to add one that's definitely not in this list, right? Because I'm working through the instructions of this and I'm trying to make sure I handle all these kind of cases it talks about. Okay, so it should print that the item is being added to the order. So then like if item is not present, print that it's adding it to the order. So I'll look down here. I mean, honestly, you don't have to use this exact syntax. Like if you just said like add whatever, it'd be fine. But I just gave a little example here. Um, so adding, and then I would, want to print my item. Okay. You should also handle the case where the input toppings are in the list, but not plural. Okay, so I do have this case where cheese is technically in the list, but it's not plural. So then I'll need to do like if item is in list, but doesn't have that S. It should be marked as present since it's topping list. Once all missing toppings have been printed out, then it should print good to go. Okay. Then we are fine. And then so once once all the added things have been printed and it's been checked that every other item is good, then we print good to go. So then maybe I do just want to kind of end my function, right, with good to go. So the kind of print thing I'll need to do is if I'm adding an item. So that's kind of one way to break it down. So, I'll get an input list and I will want to compare my elements of a list to this. So there's several ways you can do it. You can loop through items in this list. Sorry, I heard like a Google noise, but I don't think I have my Gmail up. Oh, but yeah, so you're gonna want to kind of like loop through maybe this input list and then try to see if it's present in this toppings list and also check for the case where I may not have a pluralized thing, like I would want cheese to match cheeses. So I would need to kind of consider that in my check. And that's kind of all I want to touch on that for now. But we'll do some iteration, looping through my items. And then I think the kind of hard part is how would I get cheese to match to cheeses? I mean, there's several ways you can do it, but pastry boxes is the next one. A local cafe sells pastries in boxes 7 at a time. So I read this and I'm like, oh, did he copy the storage container question we already had? And the answer is kind of. I think this is a good example of covering topics we did and kind of gets at the storage container problem at the same time, which I think was from the homework. So everyone should have feedback on that, but I think that may have been one everyone basically got correct. But maybe we're applying something similar here. So 7 at a time. Actually, since we're running out of time, I might just skip to word match. Similar to storage container problem. And then case where it's the weekend. So check for Sat or Sunday. So that's basically with pastry box, right? Word match. So the idea for this is kind of similar, right? So this we would match onion to onions, right? And it's like a letter off, right? It has the additional S. So maybe taking what you do in here, you could also kind of apply to word match, because the idea with word match is we take in a word, and that's going to be like a string. Let's do here. And then you take in a word list. I'll comment it because I don't want to reassign it. And I'll just copy this one right here. And so I'm going to want to match my input word to any in this list. And that includes ones that have a slight modification. And so, for instance, adding a letter to the beginning of the word or to the end. Where's that? Yeah, right here. Adding a letter to the beginning or end of the word and changing a single letter in it. So I kind of broke down all the cases here, but I think I did potentially miss one that could cause some confusion. So someone asked on Piazza. Thank you for that. If because I gave, where's the example of it? Yeah, so wow matches with like so, and that's because if you change the W to an S, it's the exact same word. But the same would apply if the word was in the middle. So for this ham one, if our word list had him in it, then it would match. So like ham would match him. I'm gonna type this out. So it's still the case, right, where it's a single letter being changed, but it's fine if it's in the middle too, because I know the case I gave was when it was at the beginning. But just quickly, how I might break this down. Function takes in two parameters. Oops, sorry. Yeah, throw that over there. All right, function takes a single word, and second parameter word list. Also, too, when I kind of see examples, I go ahead and maybe like code them in here because this is a realistic example. So I can assume I'm working with this kind of input right now. So I kind of already have that first sentence done. All are lowercase, so I won't need to call anything. The function should check if the input word is in word list. All right, seems easy enough. All right, return the word. Otherwise, the function should check every word in the input word list and see if the input word can be obtained by making a slight modification. So this is kind of the hinting language too, when you read like should check every word in the input word list. So check every word in a list. So, okay, loop over items in word list. And so maybe I'm already kind of baking that in too. If I'm already looping over the items, I can do the check here to like if word equals an item in word list. But then what was that thing about the modification? So then I might say, okay, this includes adding a letter to the beginning or end of the word. Okay. So if I'm like if letter plus word equals an item in a word list, and then if word plus letter equals item in a word list, then yeah, I might want to like return item because it says we need to return that word. Okay, so that's a letter plus the word is item, word plus any letter. Okay, and then what's the other case where it matches? Changing a single letter in it. So then maybe I need to say somewhere. It's like, okay, well, how am I going to check for like if just one changed letter to it is going to do it? So it kind of says if a single changed letter. So that lets me know if like two or more are changed, then it's no match, right? Because we just want the case where it's like ham matches him and wow matches so. Um, so it's like, okay, well, if I'm gonna want to check for a letter, then maybe I need to like iterate over the letters in the item in word list. Perhaps that's one way I could do it. Because right, if I'm like have this word wow, and then I want to see if it's, which is like, I'll put this back in a comment, see if it's like so. Then maybe I'd want to check like, hey, does that W equal my S? No. But then if I do that for the other letters, cannot type. Actually, we'll just do this. Then it's good, right? So that's a case where it would work. But then, if my input word was like this, I don't even know that's a word, then it'd be false. And so it would not be good because we have more than one word that's changed. And so maybe even after that point, now that I now have two falses, two letters that don't match, I could just stop and I wouldn't have to go on to this comparison. So, maybe I do need to do a little letter iteration there for one way. But yeah, that's kind of, I don't want to dive into this too much more, especially because we'll have Thursday's labs and Sunday's office hours. So there's at least two more kind of office hours recitations before any of this is due. So if you are totally confused by everything I just kind of covered right here, maybe look at it before Thursday or Sunday and come in with some questions for me. Otherwise, Thursday I will be going over our lab for this week and solving it. And I think we'll probably have extra time, at least maybe 20 minutes or even half an hour Thursday. And I might kind of touch back on this homework a little bit more or just any concepts that people may be posting about in Piazza or elsewhere. But I think that's it. I'm going to sign off now, unless there's any questions. And since there is like a 20-second delay or whatever, I will wait like 30 seconds. So this actually gets relayed to y'all in case there are any questions. But if something does come up while you're working on the homework or lab for this week, feel free to post on Piazza or shoot me an email or something. I guess I slightly prefer Piazza so we can kind of share the knowledge. But right, yeah, you're gonna have to do the case where the letter plus the word can definitely get into range issues. So that can be a little tricky, which is again another case where you might want to be printing a lot, especially if you're doing indexes. Oh, and one thing to note too, if I can make this a little bigger, is just don't forget if I have a word like swimming again, that you can index into this like a list, right? So, we'll get the whole word. But as you mentioned, so we're good there, but we can get the whole index out of bounds there, just like we would expect with a list. So, as a list is 0 indexed, and, the fourth element right here is the third index. Similarly, in swimming, the fourth element, which is the M character or letter, is the third index. So you can kind of treat that iteration-wise like a list. That might be helpful. But yeah, I believe in y'all. You already know that you might run into trouble with that kind of whole index thing, so I feel like you got the jump right there. because that is definitely something you want to watch out for. And I'm super interested to see how everyone kind of solves it. It was really cool grading the first homework, seeing the kind of different ways, but I can't wait to dive into kind of homework 2 for something like Dice Game, where it was a little more lengthier, and kind of enabled a little more freedom in a way to see the different ways everyone kind of solved it. Because to me, that's really interesting. And I think this one, there's going to be so many different solutions that still get the same answer. That actually might make grading a little bit of a pain, but it's cool to see everyone's kind of thinking and thought process and workflow. And I think this is pretty representative of something that you might encounter kind of like in the wild, where it's going to be a little complicated. There's different ways to solve it, but you know, and it can have applicability. I mean, this is like, though, if you do have like this word list and so, where do you live? And you say like, oh, or where do you go to school at? And someone has a typo in Pittsburgh, they leave the I off. We would still maybe want to match that to Pittsburgh. Um, so, this is one way you could do it. And when you are making these kind of prototypes for like Capstone and PUI, uh, and you do want to say like to the client or for the project that, oh, we have like an autocomplete or we have something that gets it close, you could actually kind of implement something like this. So trying to keep the applicability there. But all right, signing off. Hope everyone has a great week. Don't forget the labs due Thursday, quiz due Friday, and the homework is back on the regular schedule of Monday. And again, I'll get the grades out for week 2, probably by Friday. And yeah, post on Piazza or anything if you need help. And I'll see you all Thursday.